sand is red. Not the dull tan of a dry riverbed or the pale yellow of a dune you have seen in a photograph. Red, a deep, iron-soaked red that looks like the earth has been holding its breath for 1,000,000 years, and the color leaked through. It stretches across the southern tip of Africa, catching the first light of morning on the crests of the dunes until the whole horizon burns from below, as if the planet itself is lit from the inside. Stand in the middle of it before the heat arrives, and the silence is not just the absence of sound. It has weight. It presses against you the way cold water does. It is the silence of a place that has been running the same test on everything inside it for tens of millions of years. And it does not care how you feel about the exam. What if I told you that one of the animals living here, a large antelope with horns like spears and a face painted in war colors, voluntarily raises its own body temperature to 45 degrees Celsius just to save water? That inside its body, in that heat, it keeps its brain cooled through a separate biological system while the rest of it bakes. That it has been doing this every single day in this exact desert since before our species existed, not as a sign of desperation, as a strategy so refined it has not needed to change in millions of years. I remember reading about the Kalahari for the first time and thinking nothing could survive here. The heat alone would end it. And then you read the numbers. 300 species of birds, lions, cheetahs, leopards, wild dogs, meerkats that have developed what amounts to a language, a formal teaching method, and a community health system. A bird the size of a sparrow that builds a house weighing 1,000 kilograms, that stays warm in winter and cool in summer without electricity or insulation, built from grass and 10,000 years of learned behavior. The Kalahari is not a dead place. It is one of the most alive places on Earth. It is just alive in a way that required everything inside it to become something extraordinary. Drop a comment right now and tell me where in the world you are watching this from. It matters to me. I want to know what corner of the planet someone wakes up in and decides today they want to understand the Kalahari. Now, let us go. The Kalahari covers approximately 900,000 square kilometers across Botswana, Namibia, and South Africa. That is larger than Texas and California placed side by side. Scientists classify it not as a true desert, but as a semi-arid savanna, because its annual rainfall of roughly 150 to 500 millimeters, depending on region, technically crosses the threshold for supporting vegetation. Do not let that classification comfort you. The rain arrives in violent storms concentrated between November and April, and then disappears entirely for the next 7 months. What falls is swallowed almost immediately by the ancient porous red sand, sinking beyond the reach of most root systems within hours. The surface stays dry. The heat stays total. Summer afternoons reach 45 degrees Celsius on the ground. Winter nights in the south dip below -15. The air holds so little moisture that water evaporates from your skin faster than you can feel it. This is a landscape that withholds relentlessly the one thing every living thing needs most. And yet, it is full. Completely, improbably, stubbornly full of life. The red color of the dunes comes from iron oxide, rust essentially, embedded in the ancient sand grains and accumulated over millions of years of weathering. Beneath the dunes, if you dig deep enough, you find layers of older soil, fossil riverbeds, the remnants of a landscape that looked completely different in wetter geological periods. The Kalahari has been through flood phases, and near-Saharan dry phases, and everything in between. The animals and plants alive in it today are the descendants of organisms that survived every one of those transitions. They carry the memory of those cycles in their genes, and that accumulated resilience is part of what makes the Kalahari's current inhabitants so precisely equipped for what the desert does to them. The Kgalagadi Transfrontier Park, spanning 3.6 million hectares across South Africa and Botswana, protects the heart of the southern Kalahari and became one of Africa's first formally designated peace parks in the year 2000. The dry riverbeds of the Awob and Nossob rivers cut through its landscape, ancient channels that carry surface water only in the rarest wet years, but whose subsurface moisture sustains the root systems of the camel-thorn acacias through the long dry months. Along these riverbeds, life concentrates. Waterholes dug by hand over a century ago in search of livestock. Water have become the permanent stages where the great Kalahari dramas repeat, night after night, generation after generation. A waterhole in the Kgalagadi at midnight, with black-maned lions sprawled in the dust and a line of Gemsbok testing the air from 200 meters away. Deciding whether to approach or turn back is one of the oldest ecological conversations still happening anywhere on Earth in something close to its original form. The Gemsbok is the animal whose image appears on the national coat of arms of Namibia, and it is the animal that more completely than any other living thing in the Kalahari embodies what this desert demands of the things inside it. An adult Gemsbok stands 1.2 meters at the shoulder and weighs up to 240 kilograms. Both males and females carry horns. In most antelope species, horns are primarily a male feature, a tool for competing over mates. But female Gemsbok have horns that are, if anything, more impressive than the males, longer and thinner, reaching up to 120 centimeters. This is a telling detail. These horns are not sexual ornaments. They are weapons, and both sexes need them at full capability because in the Kalahari, the predators do not care about your gender. Female Gemsboks have killed lions, not grazed a lion, not discouraged a lion, killed. One precision strike from a horn that rigid and that long, driven by the momentum of 240 kilograms of panicked or cornered animal, is enough to penetrate vital structures in a lion's body. Gemsboks back themselves against thorny acacias when cornered, protecting their flanks and hindquarters, and face predators head-on with both spears aimed. It takes an average of 4 spotted hyenas working in coordination to bring down a single healthy adult Gemsbok. That statistic alone tells you everything about what this animal is. The Gemsbok's relationship with water is one of the most extraordinary things in the animal kingdom. It does not have a dependence on drinking water the way most large mammals do. It can survive for months without any access to liquid water at all, extracting all the moisture it needs from its food. It grazes primarily at night and in the early morning when the moisture content of plants is highest. It digs for tsama melons, those wild desert fruits the size of a grapefruit that store water in their flesh precisely as a dry season mechanism. And when even those are gone, it excavates deeper, pushing its hooves into the sand to reach tubers and roots that hold moisture locked inside them at depths half a meter below the surface. It has specialized kidneys that recycle water from its own urine back into its bloodstream before excretion, reducing loss. And it has something in its skull that ranks among the most elegant pieces of biological engineering produced by any species anywhere on this planet. The carotid reed. It is a dense mesh of fine blood vessels located where the main artery carrying blood to the brain passes close to the veins, returning blood from the nasal passages. When the Gemsbok breathes, air moving across the moist nasal membranes cools the blood in those return veins. That cooled blood surrounds and chills the blood in the carotid artery before it can reach the brain. The result is that the Gemsbok's brain stays at a safe, functional temperature, while the rest of the animal's body climbs to 45 degrees Celsius, absorbing and storing the desert heat the way a battery absorbs charge. It dumps that stored heat into the cool night air when the sun goes down. It barely sweats. It barely loses water. It operates in conditions that would cause fatal brain damage in most other large mammals. At full function, the Gemsbok does not fight the Kalahari. It uses it. In the Kgalagadi, Gemsbok make up approximately 32% of lion kills and 52% of hyena kills, which tells you both how numerous they are and how central they are to the desert's carnivore economy. Without the Gemsbok, the great predators of the Kalahari have no engine to run on. Speaking of those predators, the Kalahari lion has been shaped by this landscape into something different from the lions of the Serengeti or the Masai Mara. The same species, but a different expression of it. The males develop manes that range from a pale gold through every shade of brown and black to a deep, full jet black that gives the most dominant individuals their well-earned name, black-maned Dune Kings. That mane is not decoration. It is information, and it is honest information, which is the only kind that survives long-term in a competitive ecosystem. Maintaining a thick, dense, dark mane in the Kalahari heat is physiologically expensive. The darker and fuller the mane, the more heat it traps around the lion's head and neck, the more the lion must dissipate through other mechanisms, the more energy the whole process costs. A lion carrying a full black mane is broadcasting through the simple fact of being able to afford it that he is healthy enough, dominant enough, and consistently well-fed enough to bear that cost. A sick lion, a subordinate lion, a starving lion loses the mane. Nature does not allow fake credentials in a system where rivals are watching constantly. The signal is real because faking it is too expensive. Kalahari lion prides patrol home ranges that can reach 2,000 square kilometers, compared to the 20 to 400 square kilometers typical of savanna prides. This is the direct result of living in a landscape where prey is dispersed rather than concentrated, where there is no permanent river with a permanent hippopotamus pod and a permanent wildebeest herd grazing nearby. The lions walk, and walk, and walk. Days without food are not crises in the Kalahari. They are routine. The females who perform the majority of the hunting are built accordingly. Lean, endurance-shaped, with muscles refined by constant movement across sand and open ground, rather than the explosive, short-distance effort that defines savanna lion hunting. When Kalahari lionesses stalk, they use the dune topography as concealment, moving through the low ground between dune crests, appearing suddenly at the ridgeline to cut off angles of escape that would be obvious on flat savanna ground. It is a hunting technique that evolved in direct response to this specific landscape, and watching it play out is watching learned strategy as much as instinct. The interaction between Kalahari lions and African wild dogs produces a continuous ecological story. Wild dogs in the Kgalagadi have been observed swallowing their kills with urgency and efficiency that researchers initially interpreted as a species behavior. It turned out to be a behavioral adaptation to a specific social environment. The dogs had learned that lions track the sounds of a successful hunt and arrive to steal the kill, and they had adjusted how they eat accordingly. The lions changed how they patrol in response to the dogs. The dogs changed how they consume in response to the lions. Two predator species locked in a relationship of competitive theft that neither can fully escape from in a landscape that confines them to the same resources, continuously refining their responses to each other. This is the silent war the title speaks of. Not just predator and prey, though there is plenty of that. The deeper, older, quieter war between species competing at the top of the same food web, each one forcing every other to become more precise. Somewhere near the lions, using the lions' abandoned sleeping places for warmth on cold mornings, is a creature that runs the most sophisticated small mammal society documented anywhere on Earth. The meerkat weighs 730 grams and stands 30 centimeters tall. It is small enough to be taken by a martial eagle in a single swooping strike, or by a puff adder if it gets its approach angle wrong, or by a jackal if it wanders too far from its group. Given those facts, it seems surprising that meerkats forage in the middle of the day, in the open, in the most predator-dense landscape in Africa. But that apparent recklessness is not recklessness at all. It is a precision system built from collective intelligence and made reliable through millions of years of social refinement. Meerkat mobs range from 10 to 30 individuals. All are related. All operate within a strict hierarchy with a single alpha female at the top whose hormonal state actively suppresses the fertility of every other female in the group. In a functioning mob with a healthy alpha, almost all reproduction flows through one female. Her pups are the genetic future of the entire group. Everyone else is the infrastructure. The hierarchy is not merely social, it is biological, enforced at the chemical level, and it produces a group that functions with the coordinated efficiency of an organism rather than the loose association of individuals. Before the mob disperses to forage each morning, and at least one member climbs to the highest available point. A termite mound, the most useful structure the Kalahari provides, rising a meter or more above the flat ground and offering a 360-degree view. The sentinel stands on that mound, upright on its hind legs, pale belly facing the rising sun, and begins its constant soft call. That call is the baseline. The foraging mob heads down in the sand digging for scorpions, and beetle larvae and small lizards, hears that call and registers. Safe. The moment the call changes, pitch or pattern or urgency, every individual in the mob reads the new information without hesitation. An aerial alarm, a specific call encoding the approach of a raptor from above, sends every mob member sprinting for the nearest burrow entrance within seconds. A ground predator alarm, a different call with a different pattern, produces a different response. The mob bunches together and turns to face the threat collectively. The combined visual presence of 20 or more small alert animals, often enough to make a jackal or a monitor lizard decide the risk is not worth it. Researchers have catalogued at least 12 distinct meerkat vocalizations, each carrying specific information about predator type and direction, distance and urgency. The information density in these calls has been compared in academic literature to structural properties of human language. The sentinel standing at dawn is also doing something physiological that is easy to miss. A meerkat that has spent the Kalahari night in a burrow where temperatures drop below zero emerges with a body temperature it needs to raise before its muscles can work efficiently enough to forage or flee. The pale fur on its belly absorbs solar radiation faster than the darker fur on its back. The upright posture maximizes the surface area in direct contact with the low-angle morning light. The animal is not standing there because it feels like it. It is running a warming protocol that takes approximately 20 minutes on a clear morning before the mob can begin its working day. Two functions, sentinel duty and thermoregulation, executed simultaneously by a single behavior in a 730-gram animal. The Kalahari's solutions rarely waste resources on single purposes. Meerkats are partially immune to the venom of the scorpions and snakes they regularly eat, a resistance that appears genetically encoded rather than individually acquired. But genetic resistance does not teach a young meerkat how to find and disable a scorpion safely. That knowledge comes from other meerkats. At the Kalahari Research Center, which has tracked individually known meerkat families since 1993, in what has become one of the longest-running animal behavior studies in the world, researchers documented something that changed how biologists think about animal intelligence. Adult meerkats act as deliberate teachers. When an adult brings food to a pup old enough to begin learning, it does not simply drop the prey item. It presents the prey item at a difficulty level calibrated to the pup's developmental stage. A very young pup receives a dead scorpion. No danger, just food. An older pup receives a live scorpion with the stinger removed. A still older pup receives a fully intact, fully capable live scorpion. A genuine challenge requiring the pup to deploy what it has learned. The adult assesses the pup's response and adjusts the next lesson accordingly. This is not instinctive food sharing. This is a teaching progression with graduated difficulty, real-time feedback, and deliberate adjustment. It is the clearest example of intentional pedagogy documented in any non-human animal. When the alpha female nurses pups, subordinate females in the mob, females who have not given birth, often lactate and nurse those pups alongside her. This is called allosuckling. And the additional nutrition it provides can be the biological margin between a pup that reaches adult body weight and one that does not. Other helpers carry food to the burrow entrance, babysit while the rest forage, and rotate sentinel duty so the breeding female can spend the maximum possible time eating during the critical weeks when she is nursing. Pups born into mobs with more helpers survive at measurably higher rates and reach adult size sooner. The social structure is not preference. It is a precisely calibrated survival system that the desert selected for, and the animals have been running reliably for millions of years. High in the camel-thorn acacias above the Meerkat territories, or along the telephone poles and fence lines that cross the southern Kalahari, the sociable weaver has been building something that challenges the meaning of the word nest. A sociable weaver is a small brown bird, 27 grams, easily confused with a sparrow. Not fast, not colourful, not loud, and yet it constructs collectively and continuously the largest bird nest on Earth. A mature sociable weaver colony nest can span up to 6 meters across, stand up to 2 meters in height, and contain up to 300 individual nesting chambers inside a single continuous thatched structure. The combined weight of a large established nest reaches 1,000 kilograms, heavy enough to collapse the tree or pole bearing it if the structure grows large enough. Some of the great sociable weaver nests of the Kalahari are estimated to be more than 100 years old, maintained continuously by generations of birds who were born inside the nest, lived their lives inside the nest, and died without ever sleeping anywhere else. The construction is not accidental. The outer layer is a tightly interlocked roof of coarse, dry grass that sheds rain efficiently. The entrance tunnels to each chamber angle downward, making it difficult for predators to enter without losing their grip, and their interior walls are lined with sharp grass stems pointing inward, a passive deterrent for snakes attempting to slide through. The chambers themselves are lined with soft plant material, feathers, and animal fur, and the thermal performance of the completed structure is extraordinary. On a Kalahari summer afternoon, when the external air temperature reaches 40 degrees Celsius, the interior of a chamber maintains approximately 23 degrees. On a Kalahari winter night, when the outside air drops below zero, the chambers remain above 7 degrees. This is a passive climate control system of remarkable engineering efficiency, built from grass and instinct. No blueprint, no architect, no measurement, just the accumulated behavioral precision of a species that has been solving this specific problem long enough to solve it perfectly. Pygmy falcons, the smallest raptors in Africa at approximately 20 centimeters long, nest almost exclusively inside sociable weaver colonies, using peripheral chambers that the weavers appear to permit. The falcon pair's presence has been observed to reduce the number of snake predation events on the colony, and the weaver's tolerance of the falcons appears to reflect the practical value of that protection. The weaver provides housing. The falcon provides security. It is a relationship that operates as a genuine mutual arrangement between two entirely unrelated species sharing the same structure in the middle of the Kalahari, which is a small reminder that competition is not the only organizing principle of wild ecosystems. Across the flat pans between the dune systems, in herds that catch the morning light and seem to shimmer as they move, the springbok are already foraging. Medium-sized, 33 to 48 kilograms. Chestnut and white, with that distinctive fold of skin along their flanks that fans open into a flash of white during moments of excitement or alarm. Springbok are the numerical backbone of the Kalahari. They are what the lions eat most consistently, what the cheetahs are evolved to pursue, what the wild dogs coordinate to bring down on a long chase across open ground. The entire carnivore community of the Kalahari is economically dependent on springbok, the way most economies are dependent on a single primary resource. If the springbok population fails, everything above it in the food web begins to fail too. The springbok's most famous behavior is pronking, also called stotting, in which the animal leaps stiff-legged into the air with all 4 feet leaving the ground simultaneously, the white dorsal fan fully spread, the back arched. The leaps can reach more than 2 meters in height. The evolutionary debate around this behavior has run for decades, but the most supported explanation is that it is an honest fitness signal directed specifically at predators. A springbok that pronks at a cheetah that has just begun stalking it is performing a demonstration of physical capability. It is saying, through the quality and height and repetition of those leaps, that it is at peak physical condition and not worth the energy of a full pursuit. The signal is honest because an animal that is injured, sick, or nutritionally depleted cannot fake a high-quality pronk. The performance requires genuine muscular power. A cheetah watching a springbok pronk enthusiastically and selecting a different non-pronking target is making a statistically correct decision that evolution has repeatedly rewarded. The pronker survives, its genes continue. The behavior continues with them. The cheetah that hunts springbok in the open Kalahari is working in conditions that reveal both the best and worst aspects of its design simultaneously. Its speed, the fastest of any land animal at up to 110 or 120 kilometers per hour, is devastating on open ground where concealment is minimal, and the prey can be run down in a short chase. But that same open ground means the springbok detects the cheetah from far away, often from hundreds of meters before any reasonable stalk can begin. A springbok with sufficient warning and sufficient distance is usually a springbok the cheetah cannot catch. The Kalahari cheetah has refined across generations of selection the art of reading vulnerability, selecting the individual in a herd whose attention has drifted by half a second, selecting the one at the outermost edge of the group, selecting the one whose escape angle is blocked by the terrain or another animal. The open desert is both the best stage for the cheetah's speed and the worst stage for its stealth. And the animals that succeed here have become extraordinarily precise judges of the single moment when speed and opportunity align. The brown hyena, larger and shaggier and far less famous than its spotted cousin, covers up to 35 kilometers in a single patrol through the Kalahari, following a nose that ranks among the most sensitive chemical detection systems in the carnivore world. It locates carcasses, abandoned kills, eggs, wild melons, insects, and the cached food of other predators. It caches food itself, hiding pieces of carcass for retrieval days later, which requires a spatial memory for specific locations across a wide, largely featureless landscape. The brown hyena avoids direct confrontation with lions and spotted hyenas, operating in the deepest hours of the night when they are at rest. It is the Kalahari's most thorough scavenger, the organism ensuring that nothing organic goes entirely to waste in a system where the cost of waste is survival. And then the rains come, and the Kalahari becomes something else entirely. The first storms of the season build on the afternoon horizon as walls of cloud that tower 15 kilometers into the sky before they collapse in downpours that pound the red sand until the surface runs with water. dry riverbeds fill within hours. The vast salt pans of the Kgalagadi in northeastern Botswana, white and cracked and empty for 9 months of the year, flood into shallow inland seas that stretch to the horizon in every direction. And within days of the water's arrival, the desert transforms. Grasses push through the sand surface across thousands of square kilometers simultaneously. Dormant seeds triggered in hours by moisture. They have been waiting for through 9 months of desiccation. Wildflowers appear in sheets across dune faces that looked biologically inert a week before. Flamingos arrive at the Kgalagadi pans within days of the flooding. Tens of thousands of them, so precisely synchronized with the water's appearance that researchers believe they detect rainfall from hundreds of kilometers away and orient their movement accordingly. They breed on the pans, building their conical mud nests in water shallow enough to stand in but deep enough to discourage terrestrial predators. For the weeks the flooding holds, the Kgalagadi becomes one of the largest flamingo spectacles anywhere on the planet. A pink and white city of birds in a place that looked like the moon a month before. In 2012 and 2013, researchers using GPS tracking technology discovered something about the Kalahari's seasonal transformation that had been happening every year in plain sight without being properly documented. 2 separate zebra migrations, each covering approximately 250 kilometers, were recorded as systematic responses to the arrival of the seasonal rains. One of these, the movement of zebra from the Okavango Delta region to the Kgalagadi pans, is now recognized as Africa's longest terrestrial wildlife migration. The animals follow rainfall signals along routes established over generations. This had been happening every year, witnessed by the San people for thousands of years and by visiting researchers for decades. But the technology to track it continuously from start to finish had only recently become available. The Kalahari keeps its secrets for as long as it takes. And then the rains stop. The pans evaporate. The flamingos lift and leave. The zebras migrate back. The grass is dry. The sand reasserts itself. And everything that earned its place in this desert during the wet season returns to the dry season strategies that the Kalahari has been refining in its inhabitants for millions of years. The pressures on the Kalahari's ecosystem now are pressures it was not built to handle. Climate models for southern Africa project longer dry seasons, more unpredictable rainfall, and higher average temperatures across the region by the end of this century. Animals and plants, calibrated to a dry season baseline that took millions of years to set, are facing a baseline that is shifting faster than biological adaptation can respond to. Prolonged droughts have already caused documented population crashes among Gemsbok and other large herbivores in the southern Kalahari, with severe dry years killing significant proportions of local herds before the rains finally return. Veterinary fences erected across the Kalahari in the 20th century to prevent foot and mouth disease transmission from wildlife to cattle cut directly across the traditional migratory routes of wildebeest and other animals that historically moved hundreds of kilometers in response to rainfall patterns. Wildebeest arriving at fence lines could not pass. They piled up and died. The blue wildebeest population of Botswana collapsed dramatically in the decades following major fence construction, declining from hundreds of thousands to populations that have not recovered to historical levels. Some fence removal and the creation of wildlife corridors have helped, but the recovery is incomplete, and the lessons of the fence catastrophe have not been fully translated into current land management policy everywhere they need to be. Farmers who use poisoned carcasses to target jackals and caracoles that prey on livestock kill non-target species at rates far exceeding the intended targets. Raptors, vultures, brown hyenas, honey badgers, and other scavengers that consume poisoned carcasses die of secondary poisoning. Martial eagles and other large birds of prey, already under pressure from habitat loss and direct persecution by people who believe they threaten livestock, are among the most consistent victims. An ecosystem that evolved an intricate network of scavengers and decomposers to process organic material efficiently is disrupted when the scavengers are selectively removed from it. And yet the Kalahari holds. The Kgalagadi Transfrontier Park sustains a functioning predator and prey system that has disappeared from most of the rest of the continent. The Kalahari Research Centre's Meerkat study, now more than 30 years old, continues generating findings that have reshaped scientific understanding of social evolution, cooperative behavior, and animal cognition in ways that reach far beyond the Kalahari itself. The Kalahari has always been a test. It tested the Gemsbok until the Gemsbok invented a refrigerator for its brain. It tested the lion until the lion developed legs designed for 2,000-kilometer territories. It tested the meerkat until the meerkat built a teaching system and a healthcare network and a language. It tested the sociable weaver until the weaver built a house that 100 years of Kalahari weather has not brought down. The desert does not apologize for its tests. It simply administers them continuously and without pause to everything inside it. What survives here is not the strongest. It is the most exactly right. And there is something worth carrying from that. Something that applies far beyond the red sand and the acacia trees and the morning sentinel standing with its face to the rising sun. The African wild dog, running in packs across the Kalahari in coordinated pursuits that can cover several kilometers, represents one of the most endangered large carnivore species in Africa. Fewer than 6,000 remain in the wild across the entire continent, and the Kalahari and its surrounding ecosystem provide critical refuge for a population that has been pushed out of most of its historical range by habitat loss, disease, and direct persecution. Wild dogs hunt with a success rate of approximately 80% of hunts ending in a kill, the highest documented rate of any large African carnivore. Lions manage roughly 25 to 30%. Cheetahs somewhat higher in ideal conditions. The wild dog's efficiency comes entirely from coordination. Pack members split to cover multiple escape angles. They communicate constantly during pursuits through high-pitched calls and body posture. They take turns at the front of a long chase, the lead animal dropping back as it tires and another taking the front, so the collective pace remains higher than any individual dog could maintain alone. Every member of the pack is essential to the strategy. Every absence costs efficiency. The wild dog has built its survival entirely on the premise that together, the pack is more than the sum of its parts. This pattern appears repeatedly across the Kalahari's social species. The meerkat mob that teaches allosuckles and sends helpers to babysit pups. The sociable weaver colony that collectively maintains a thermal structure none of them could build alone. The wild dog pack that hunts with a coordination that has been refined across generations of shared pursuit. The Kalahari keeps selecting for cooperation over individual strength at every scale, from 27-gram birds to 30-kilogram dogs, because cooperation in a resource-scarce environment produces higher survival rates than competition. The desert keeps teaching the same lesson, and its inhabitants keep learning it. The pangolin, one of the Kalahari's most elusive residents, is covered from head to tail in overlapping scales of keratin, the only scaled mammal on Earth, and is simultaneously one of the most trafficked wild animals in the world. Its scales, falsely believed by some markets to have medicinal properties, are composed of the same protein as human fingernails and have no documented pharmaceutical value whatsoever. The demand for those scales has pushed every pangolin species across Africa and Asia closer to extinction, with a speed that the animal has no evolutionary response to. In the Kalahari, the pangolin moves at night on short legs, navigating by smell, locating termite mounds and ant colonies by chemical detection, and excavating them with powerful claws while sealing its eyes and nostrils against the swarming insects. Its tongue can reach 40 centimeters. When threatened, it rolls into a ball so complete and so tightly locked by the overlapping scales that most predators cannot open it. The threat it cannot roll away from is human demand, which moves faster than any predator this animal evolved to survive. The porcupine, nocturnal and heavily armored with quills that are modified hairs with barbed tips, does not launch those quills, a popular misconception. What it does is back rapidly into anything threatening it, driving the quills forward and into whatever is making contact with enough force to embed them deeply. Lions in the Kalahari have been found dead of infections that began with a single quill driven into the face or foot during a failed predation attempt. The porcupine does not need to win the fight. It only needs to make the fight expensive enough that the predator decides the cost exceeds the value of the meal. In the Kalahari, the secretary bird strides across the open plains on legs that look borrowed from a crane, hunting snakes by a method that should not work as reliably as it does. It attacks directly. It stomps. Repeatedly, rapidly, with feet capable of delivering a blow force estimated at several times the bird's own body weight. It kills puff adders this way, and Cape cobras, and various other species that would hospitalize or kill most creatures attempting the same approach. In a desert where venomous snakes are both abundant and genuinely dangerous to the other species living here, the secretary bird's willingness to attack them directly keeps snake population densities at manageable levels for everything else. It is not glamorous work, it is essential work, and the secretary bird has been doing it every single day across the full length of the Kalahari for as long as there have been snakes here to hunt. The bat-eared fox uses ears proportionally enormous for its body size to serve two functions simultaneously. Those ears rotate independently to triangulate the underground location of harvester termite colonies by the sound of insect movement through soil tunnels, allowing the fox to dig precisely above the highest termite density rather than excavating randomly. And the same ears, with their large surface area threaded through with blood vessels, radiate body heat away from the fox's core in the manner of a radiator, keeping internal temperature manageable even as the Kalahari afternoon approaches 40 degrees. One structure solves two separate problems. The Kalahari rarely allows single-purpose adaptations to persist. Every species in this desert is a solved problem. A problem that was posed by the landscape and answered over millions of generations until the answer became precise enough to work reliably. And those solutions interact. The silent war is not a metaphor for simple predation. It is the entire system of pressure and response, of solution creating problem creating solution, that has been running continuously in this red sand desert since before any of the animals in it existed in their current form. The Gemsbok's horns are part of the war. The lion's mane is part of the war. The Meerkat's teaching curriculum is part of the war. The sociable weaver's thermal engineering is part of the war. It is a war in which every participant is simultaneously predator and prey, here engineer and raw material, solution and problem. And the only way to win is to become so precisely adapted to your role that you cannot be replaced. The Kalahari has been running this war for longer than our species has existed. It will continue running it if the conditions that allow it to continue are protected for longer than our species will last. What happens inside this red desert in the next century will depend, more than it has depended on anything in the last 10 million years, on decisions made by people who may never stand in the middle of it and feel the silence press against them like deep water. That is the strange and somewhat humbling position we occupy in relation to this place. We are the first species in its history with the power to end what it has built. We are also the first species with the awareness to choose not to. If something from this place stayed with you, leave it in the comments. Tell me which animal. Tell me which story. This desert has been running its silent war for millions of years, and the more people carry it with them, the better chance it has of running for millions more.